8 EE.1 is about exponent rules. Number 2 says to select all the pairs of equivalent expressions. So using exponent rules, we have 5 to the third power times 5 to the first power. So we know that when we are multiplying like bases, we keep the base 5 and add the exponents 3 plus 1, which is 5 to the fourth power. 5 to the fourth power is 625, and 25 squared is also 625, so this is true. These are equivalent. The next one, 5 to the third power times 4 squared, we could just evaluate and get, well, that's 125 times 16, which is 2,000. And then 20 squared comes out to this number 64 followed by 6 zeros, which is 64 million, and that's definitely not equal. Our next set, 6 to the second power raised to the third power. When we have a power raised to a power, we keep our base 6 and multiply the exponents to get that is 6 to the sixth power. That is definitely not equal to 6 to the fifth power. Our following expression, 3 to the second power raised to the third power, that is 3 to the second times the third power, which is 3 to the sixth power. And it even breaks it down as 3 to the second times 3 to the second times 3 to the second power, which is 3 groups of 3 to the second power, which is the same as saying 3 to the 2 plus 2 plus 2 power, which is also 3 to the sixth power. Those are equal. Then our last expression, 5 to the fourth power 3 times, is like saying 5 to the 4 plus 4 plus 4 power, which is 5 to the 12th power. And 5 to the fourth power raised to the fourth power is like saying 5 to the 4 times 4 power, which is 5 to the 16th power. These are not equal to each other, so that is not equivalent. Number 4, match the equivalent expressions. 5 to the 0 power is 1. Anything to the 0 power is 1. 5 to the second power is just saying 5 times itself, which is 25. 5 to the negative second power is actually like saying 1 over 5 squared, which is 1 over 25. And then 5 to the first power, anything to the first power is just itself, which is 5. Number 5, we're simplifying this expression. We're dividing like bases. So we have 2 to the 4th divided by 2 to the 10th power. So we're going to keep our base 2 and subtract the exponents to give us 2 to the negative 6th power. But we don't want to leave a negative exponent as part of our answer, so we're going to rewrite it as 1 over 2 to the positive 6th power. Remembering that when we have a negative exponent, we can just cross that base across the fraction line and it will become a positive exponent. Standard EE.2 is about squares and cubes. Number 3, solve the equation x squared equals 6. Our goal is to get x by itself. So one way we could get x by itself is we could undo the operation of squaring x, which would mean we would take the square root of both sides of the equation. When we square root x squared, we get x. But on the right side, when we square root 6, we get a non-terminating, non-repeating decimal. So sometimes we write this in the form of what's called radical form, where we use it, we leave the square root symbol as part of your answer. So it's just square root of 6. Now, we do need to think for a minute. When you square root a value, you're finding both roots, the positive and the negative. So this means if I were to multiply the positive square root of 6 times the positive square root of 6, I get just 6. But if I multiply negative square root of 6 times negative square root of 6, the result is also positive 6. So the square root of 6 can be either positive or negative, and since we're not dealing with distance, it can be either. Distance is always just positive. So our answer here is answer choice D. Problem 6 is an application of square roots. Karen is making a frame for a square picture with an area of 169 square inches. How many inches of framing are needed? And think about the frame of a picture. That would really be the perimeter of the picture. So we want to know how many inches of perimeter there are. So we just need to know what each side of this square picture measures. So I'm going to start with saying this. I know that the area is 169 square inches. And I have a little formula for area of a square. It's not on our reference sheet, but it just says that the area of a square is the side squared. So if I know the area is 169, then I can find what the side squared is by taking the square root of both sides of this equation to get 13 is S. And we know that's positive or negative, but we have to think this is a distance. So it has to be a positive distance of 13 inches. So that's the side of a square. Now the perimeter would be taking the side of the square, and we could add it 4 different times, or we could just say that's 13 times 4. Either way, we get that it is 52 inches. Number 14, solve the equation x cubed equals 0.027. Well, we want to solve this by finding out what x is. We can undo this cubing x, which is x cubed, by doing the inverse. So we could take the cube root of both sides of this equation. On the left side, when you cube root x cubed, you just get x. On the right side, when you cube root 0.027, you get 0.3. And so the answer is answer choice A. Now, why are we not including the negative value? Well, when we multiply 0.3 times 0.3 times 0.3, we get positive 0.027. So positive 0.3 is the cube root of 0.027. However, if we multiply negative 0.3 times negative 0.3, we get positive, and then multiply that by another negative, we get a negative 0.027. And our original value is just positive. So when you cube root a value, it keeps its sign. Number 15 is an application problem with cube root. It says Lisa has a cube-shaped box with a volume of 512 cubic centimeters. If Lisa fills the box with 1 cubic centimeter blocks, how many blocks make up each layer? Well, basically, when it's asking how many blocks are each layer, it's just trying to figure out what 1 square of your cube would be, what the area of that square would be. So this problem is talking about this cube, and what I have highlighted here in pink is 1 layer of a cube, which is actually just a square. So to find out the area of that square, we need to know what each edge of the cube measures. We could use a little formula. Volume is equal to the edge cubed, because a cube has length, width, and height that are all the same. We know that the volume is 512. We don't know what each edge measures, but if we were to take the cubic root of both sides of this equation, we get the edge by itself on the right side, and the cubic root of 512 is 8. So 1 edge is 8 centimeters. But we want to know the area. We know the area of a square is just the side squared. Since that side is 8, when we square it, we get 64, and that is square centimeters. And that's how many blocks would take up that bottom layer. Answer choice B.